Today we're going to be talking about some scaling principles with volume, and then we're going to move on to our density. We've done a bunch of the scaling principles when we looked at our area and also when we looked at perimeter, so we're just going to kind of now take a look at it when we approach a three-dimensional figure. So we are told on the right-hand side we have similar figures, and we need to find the ratio of the side lengths and express it in simplest forms. So we want to compare our corresponding sides. So for instance, if I were to compare 4 to 6, going small to big, and then put that in simplest forms, I can tell you that's going to reduce to a 2/3 ratio. If I could compare, let's say, our top side here of 3, that's going to be corresponding with our top side of 4.5. And if I were to plug that in the calculator and reduce, that's also going to give us 2/3. Okay. And then our last ones, if I were to take a look at the side of 5 and compare that to the side of 7.5 and reduce, I see it's also 2/3. So this is good, number one, because since they are similar, their sides should be in proportion, in the same proportion. And I can see the ratio of those sides is going to be a 2/3 ratio. Okay, if we were to calculate the volume, so because it's a rectangular prism, I know your volume formula is big B times H. Big B is the shape of the base. It's a rectangle, so we have length times width times height. So if we do it for the first one, for our small prism, we would have, how about 4 times 3 times 5? And that's going to get us a total volume of 60 units cubed. And if we do the same thing for our big guy, okay, so same formula, so it's still length times width times height. And plugging that in, we have 6 times 4.5 times 7.5. And we're going to get something that looks like 202.5 units cubed. Okay, so now we have to take a look at the ratio of the volumes in simplest forms. So keeping it consistent with how we looked at the sides, we the small shape to the big shape, we'll do the same thing. So I'm going to take a look at our small divided by our big. And our small volume was a volume of 60 units cubed. And our big one was a volume of 202.5 units cubed. So now it says in simplest forms. Easiest way to do it, just like we did with the sides, plug it in your calculator and then do a reduction of that, the decimal, or turn it into a fraction, I should say, which is that menu 22 on your calculator on the Inspires. And when you do that, your calculator is going to simplify that for you and get you 8/27. So that's the ratio of the volumes in simplest forms. Okay, so there's got to be a connection. So our connection, it says the relationship between our answers from part A and part C. Well, the answer from A, we had our side ratios were 2/3. And the ratio from C, we just found, was 8/27. So if we take a look at our side ratio, and I think, how can I make that 2 and the 3 turn into an 8 and a 27? I take our sides and cube them, 2 cubed, and 3 cubed. So 2 cubed is really going to be our 8. 3 cubed is really going to be 27. So it looks like if we can take the ratio of our side lengths, and they are cubed, that is going to equal the ratio of the volumes. So that's really helpful, because if we don't have a volume and we're trying to find it, as long as I know the side lengths, then I can find our volumes. Now, we looked at this before when we did area. We looked at this when we did perimeter. So if we have two similar solids that have a scale factor of A to B, so in our case it was 2/3. The surface areas, this is what we did before, we said the surface areas would have a ratio of 2 squared compared to, I'm sorry, not 2, that's our previous example. In general, it would be A squared compared to B squared. And now again, that's your surface areas that we're talking about. Today we're looking at volumes and saying, well, then the volumes would be A cubed to B cubed. And I think about your units. In area, you would have units squared, and in volumes, you would have units cubed. So if you can kind of remember that, make that connection, that's going to help you with that scale factor. Okay, so trying this out, so it says two circular cylinders are similar, so meaning their sides are in proportion. It says the ratio of the areas, so understand what we're given right now, the areas of their bases is 9 to 4. Find the ratio of the volumes of the similar solids. So our goal is to find the volumes. Okay, so we have the areas. We know the areas, we're basically taking the side squared. So on the front part of the page, we said it was going to be in that a squared to b squared idea, where a and b were the side lengths. So I want to find the side lengths. In other words, I want to find out what number times itself would give me 9, or I want to square root the 9, and I also want to square root the 4. So if I square root 9, I get 3, and if I square root 4, I get 2. So what we have just found here, this is our side lengths, our side ratio. And now if I know the side ratio, now I know I can take that side ratio and cube it. So I would have 3 cubed, and I'd have 2 cubed. So 3 cubed, we're going to get 27. 2 cubed, we're going to get 8. And what they wanted to do is find the ratio of the volumes. Here's your ratio of the volumes. So first you had to find your side lengths. Did that by using our area and square rooting it. Then I could make it into a ratio of volumes by cubing. Okay, carrying on and taking a look at density. So our density problems, density formula is mass divided by volume. And a way to kind of remember that, it's dmv. D is equal to m over v. So we're going to take a look. One thing you have to be careful with, especially in these problems, is your units, to make sure that you have the same units when calculating. We're going to notice that in our first problem. So it says a square metal plate has a density of 10.2 grams per centimeters cubed and weighs 2.193 kilograms. So right there, I kind of want to stop and hold the bus and think, all right, I got to get everything into the same units. So to turn kilograms into grams, I'm going to think, move my decimal point over 1, 2, 3 places to the right. So this is the equivalent of saying 2,193 grams. Okay, now we're in the same units. Now it says we have to calculate the volume. Okay, so in order to find volume, I need density, I need mass, we have those, and if I plug it into that D equals M over V formula, okay, so we have a density of 10.2 is equal to our mass, and the mass, remember, we want it in grams so that I can keep our units all the same. Divided by volume, that's what we're trying to find. Okay, so algebra, I'd have to put the 10.2 over 1 and then cross multiply. So 10.2v is equal to 2,193. And then to solve for our volume, divide that by 10.2. We're going to find our volume for the shape is going to turn out to be about 215, don't forget your label, centimeters cubed. And we need the centimeters because if we look back at the density, the centimeters are part of our density label. Okay, so now it's saying if the base of this plate has an area of 25 centimeters squared, determine its thickness. Well, we have to go back to thinking it was a square metal plate. We have just found the volume of this. So I have a square prism, in other words. So our prism formula is big B times H, base area times height. I know the volume. I know the volume is 215, we just found that. It tells us the base of the plate has an area of 25 centimeters. So there's our base. We're looking for its thickness or its height. So solving for that thickness or the height, if I divide through by 25, I can tell you that thickness then is going to be about 8.6 centimeters. Okay, we're going to try another problem here. A little bit more in depth on this one. Again, you want to make sure that you have proper units. So a contractor needs to purchase 500 bricks. The dimensions of each brick are 5.1 centimeters by 10.2 centimeters by 20.3 centimeters. And the density of each brick is 1,920 kilograms per meters cubed. So right now, again, I'm noticing that whole centimeters compared to meters. We want to get that into the same notation. Okay. We have to figure out if the maximum capacity of the trailer is 900 kilograms, can the trailer hold the weight of 500 bricks? Okay, so first thing I would recommend is let's get all of our brick measurements perhaps in that meters. So to turn centimeters to meters, we're going to take your decimal point and we're going to move it 2 places to the left. So this is going to go 1, 2. So I'm looking at, and I'm going to write this all down all at the same time, length times width times height because it's a rectangle. So I have one dimension that's going to be 0.051. Okay. Taking your decimal point, moving it 2 places to the right for our next measurement, I have 0.102. And same thing, moving it 2 places to the right, I have 0.203. So now everything is meters. So I'm finding the volume of the shape in meters. When we multiply this out, I'm going to have 0.001056. So it's a crazy number, yes, but doable. And it's meters cubed. So we found the volume of this brick in terms of meters. Now, we want to think, all right, well, what's the mass of each of these? How much is each of these going to weigh? So again, we have our formula. We have density is equal to mass divided by volume. We know the density. The density they have told us is 1,920. I don't know the mass, that's what we're trying to find, but we know the volume of each brick. We just calculated that. That's 0.001056 and change. And again, put this over 1 and cross multiply, and that's going to tell us now our mass of each brick is about 2.0275, and keep in mind our units, we are in terms of kilograms. So it says if the maximum capacity of the contractor's trailer is 900 kilograms, can it hold the weight of 500 bricks? Okay, well, if each brick weighs about 2.02 kilograms, and I need to have 500 bricks in this trailer, that means our total weight that we're going to have is 1,013.75 kilograms. But the truck can only hold 900. So can it hold a total of 500 bricks? No, the truck can't do that. All right, it can only hold up to 900 kilograms, and we'd be way over that. So those are 2 different topics, but we're looking at the volume ratios, and we're looking at some densities. And again, we'll practice both of these in class. Hope you guys have a great day.